Now, well, what happens if you don't? Uh-oh. Okay, so if you don't make red blood cells, now you're going to have, what did we call that condition? That's going to be anemia. So now I want to talk about anemia. Wow, that was a lot already, right? Here's what I want you to do. Let's take a little break together. Okay. So now we're going to talk about anemias. You ready? Let's go. All right. So I want to talk about anemia. Many people suffer from anemia, right? And there are lots of different types of anemia. So first, let me clear off some space. And if you didn't catch all of this, that's okay. Just go back and watch the replay. So here's what I'm going to do. I'm going to clear off some space on the screen, and we're going to go into anemias. You ready? One way to figure out what kind of anemia they're going to have, or what kind of anemia they have, is by looking at the blood levels. So for instance, when you do a CBC, a complete blood count. So the CBC is going to tell you counts of, for instance, the red blood cells, it's going to tell you the white blood cells, it's going to tell you the platelet count and so forth, right? But not only does it tell you in terms of the count of the numbers of cells, it also gives you lots of other information about the blood. So we can do a CBC, a full chemistry, for instance, is going to tell you about those cells plus the electrolytes. But for instance, we can also do, let's say, a CBC with diff. So if we take a CBC with diff, that's now going to, for instance, tell you all kind of information about the different white blood cells. And I'm going to go into that next. All right, let's clear some space. Now let's go back to one of the levels, though. When you're doing the CBC, one of them is going to be what's called the MCV. What is it? Talk back to me. It's the MCV. So you're doing lab work, and one of the levels you're going to check in the blood is the MCV. That stands for the mean corpuscular volume. What does that mean? That's just a fancy way of saying what is the size of the red blood cells, okay? So one lab value that we're going to look at when in the setting of anemia is the MCV, the mean corpuscular volume. Basically, it's telling you about the size of the red blood cells, okay? Now, obviously, we're going to look at, for instance, the hemoglobin and hematocrit levels to figure out, do we just give fluids, or are they at the point where their levels have dropped low enough to where now we need a transfusion, for instance? But what I'm talking about is not so much about recognizing the anemia, but figuring out what type of anemia it is, okay? So yes, the H&H, the hemoglobin and hematocrit levels are going to tell us, okay, yes, it's now at a point where we call it anemia. But for instance, what we're talking about is what kind of anemia it is, all right? So here's what I'm going to do. We're going to look at this MCV. We're going to look at this MCV level, and we're going to separate it into what we call small, normal, and big, okay? In terms of the size of the red blood cells or the volume of the red blood cells. If they're normal, if the cells are normal, we're going to call that normocytic. If the cells are small, we're going to call that microcytic. If the cells are big, what do you think it's going to be? It's going to be macrocytic, okay? So where are we so far? We're talking about anemia, and we said that we're gonna to figure out, we've already used the H&H to determine that yes, they have anemia. Now we're going to use the MCV to lump them in different categories. And based on the MCV level, we're going to call it either microcytic anemia, normocytic anemia, or macrocytic anemia, okay? Now, what are the numbers? Getting tongue-tied over here. So, normocytic anemia is where the MCV is between 80 and 100, okay? So when you get the lab report, if the MCV is between 80 and 100, we call that normocytic. If it's less than 80, we call that microcytic. So this is really small volume. And then if it's greater than 100, we call that macrocytic. Okay, so now I want to talk about what are the different types of these different kinds of anemia. Okay, so when it comes to microcytic anemia, where the MCV is what number? It's going to be less than 80. Now, let's talk about different types of or causes of microcytic anemia. Okay, let's go back to the screen. So, one primary cause of microcytic anemia is iron deficiency anemia. Okay, so an iron deficiency anemia is one cause, and the way I remember this is, hey, think fast. Okay, we're going to think fast. FAST. The F, of course, is for iron deficiency. The A is for anemia of chronic disease. So they have some kind of disease process that's causing them to lose blood over time. It could be, for instance, it could be cancer, or it could be some other inflammatory process. There are many conditions that could cause this, but they have some kind of chronic condition that's causing them their levels to go down over time. So we have iron deficiency, anemia of chronic disease. Another one is sideroblastic. And then, for instance, the thalassemias. Okay. I'm not going to go too much in depth just for the sake of time, because I got more I want to cover. But some types of microcytic anemias are iron deficiency, anemia of chronic disease, sideroblastic, and thalassemia. Okay. And of course, with thalassemia, we can get into alpha and beta, major and minor, and so forth. But let's just keep it there for now. Now, when it comes to normocytic anemia, well, this could be all types of things. For instance, chronic disease can also fall in this category. Sickle cell can do this. Lots of different things. There's a whole list here. There are lots of different conditions that could cause a normocytic anemia. Okay. Like, for instance, let's say hemorrhage. Okay. If you're just bleeding out, if you're just losing blood, right? Let's say there was trauma. Maybe it was a car accident. Maybe somebody got shot, stabbed. They're hemorrhaging for some reason. It's not like the blood cells change size. They're just losing the blood. So that would be an example of, for instance, a normocytic anemia. Now, where I do want to focus, though, is, for instance, this category of macrocytic anemia. Okay, there are a couple different, several things could cause this, but what I want to focus on is, for instance, a B12 deficiency, vitamin B12, vitamin B9. So, for instance, we already talked about a B9 deficiency. We already call that a folate deficiency. Remember, we were just talking about folate, how it's added in prenatal vitamins to prevent, for instance, neural tube defects. Well, dark green leafy vegetables is a great source of folate. It's also a great source of iron, a plant-based source of iron, for instance. So this is a great cause for telling you, hey, make sure that you're eating fruits and vegetables and grains. Make sure that if you're not getting all the adequate nutrients from your food, make sure that you're supplementing it with some type of vitamin. So, for instance, just a good multivitamin that has, I wish I had the time to go into vitamins and really break down all the, let's say, the B complex and the C, the different water-soluble vitamins, and then the fat-soluble, the A, D, E, and K. I can do a whole 2 hours on just vitamins, for instance. Long story short is, make sure that you have adequate nutrition, because for all these different processes in your body to function properly, you definitely need certain vitamins, minerals, trace elements in your diet. Okay. Or if they're not in your diet, you've got to get them some kind of way through supplementation or some way. So just make sure that you have proper nutrition. If not, it's going to contribute to all types of problems. Okay. Now, when it comes to macrocytic anemia, we said that a B12 deficiency could cause it. B12 or cyanocobalamin, for instance, this could be, maybe they have a GI problem that affects them being able to absorb B12 properly. Maybe they have a problem maybe they have pernicious anemia, where It's a problem with intrinsic factor, for instance. So that could be any type of GI problem could lead to that. A B9 deficiency. Now, what could cause this? Well, like what could cause a B9 deficiency? Well, for instance, anti-epileptic drugs, so seizure medications could do it. Alcohol, antibiotics, chemotherapy drugs, all types of medications could cause for instance, a folate deficiency. Those same medications, so anti-seizure medications, antibiotics, anti-metabolites, um, alcohol, all kinds of medications, infections, things like that, that could affect your folate levels can now also cause you to have anemia, and that type of anemia is a macrocytic anemia or a megaloblastic anemia. Okay. Now, let's see. We covered a lot on that. Oh, I did want to. Let's go back to this part. So when it comes to the red blood cells, so I already told you how do we make red blood cells. So let's go through the process quickly. In the bone marrow, this is where it all starts out. But first, in the bone marrow, before it's a red blood cell, it starts off as a hematopoietic stem cell. Okay. Then it grows into, remember I told you that red blood cells, the immature red blood cells, what are called the erythroblasts, they're going to start in about 1 to 2 days. So it starts off as a hematopoietic stem cell, then it goes to an erythroblast, and then eventually it becomes an immature red blood cell. The term for that is reticulocyte. Okay. So reticulocytes are the immature red blood cells, and then eventually it becomes a fully functioning red blood cell. Remember, I said that a red blood cell should have this kind of donut shape. It should be biconcave, so it should be kind of sunken in on both sides. But so this would be a normal. This is just a vertical view of it. But if I here, actually, let's just flip that around. Let's take this and just flip it around like that. Yeah. So this is a normal red blood cell. Okay. And of course, it's going to have these molecules of hemoglobin. We've already talked about how do we make hemoglobin. Of course, hemoglobin is made, I'm repeating this, but hemoglobin is made from heme and globin. We went through the whole process of how do we make heme, and then that's going to hook up with the globin, form the hemoglobin, and then it's going to attach to the red blood cells. Okay. But it doesn't always go this way. Sometimes, for instance, the red blood cells can become spherical, as in the case of hereditary spherocytosis. That's where you have you're missing the proteins that deal with the structure. Those proteins are, for instance, spectrin and ankyrin. Or, for instance, let's say in the case of sickle cell, you have, instead of those alpha and beta chains that you're supposed to have, you have a different type of chain. You have, for instance, a different hemoglobin chain, and it causes a different structure, and it produces a different cell type. Okay. Let's see. So we went over anemia. We said that we're going to use the H&H level to determine they have anemia, but then we're going to use the MCV to determine what type of anemia. And we're going to break it down into microcytic, normocytic, and macrocytic. The MCV level, or the mean corpuscular volume level, of 80 to 100 is normocytic. We talked about different causes there, like chronic diseases, sickle cell, hemorrhaging, things like that, but it's a whole list of them. We talked about macrocytic, and so I said, remember to think fast. That could be iron deficiency, anemia of chronic disease, sideroblastic, and thalassemia. And then when it comes to macrocytic, that's where you got those big cells, and that could be due to a B12 deficiency or a folate deficiency. Okay? Any questions on that? All right, type that in the chat for me. Guys, we're covering a lot, and you see what I'm doing. I'm just taking basic concepts, and I'm just going deeper into these basic concepts, and we're covering all kind of ground, right? Remember, going back to those 5 levels of learning, we don't just want to know level 1, the what, or at level 2, what do the protocols say to do about it? We want to really understand level 3 is where we get to the how and the why. That's when really things start to take off. And then number 4 is where you're able to take a concept and apply it to something else, for instance, okay?